Okay, in this video, what I want to do is I'm going to go through um, problem number 8 on page 65. And my hope is that in this video, I understand that these vectors are complicated. And generally, I find that students are fine with any one part of this vector addition process. They're fine with finding components. They're fine with doing tip to tail. They're fine with finding the magnitude and direction. But it's when we put it all together that it's difficult. So what I'm going to try and do today is show you a way that you can go about this to keep the parts separate, so that hopefully um, it'll be uh, it'll be easier for you to keep everything to keep everything to keep track of everything. All right, so what we got? Number 8, vector 1 is 6.6 unit long and points in the negative x-axis. Okay, so first of all, let's define our coordinate system. So let's say y, x. Okay, so vector 1 is 6.6 units long and points along the negative x-axis. So that means it's going this direction, right? And I was hoping that would have an arrow on it, but I guess not. We'll put an arrow on it. So that's my V1, and it is 6.6 units long. Okay, and I'm just going to draw vector V2 totally different. Vector V2, it says, is 8.5 units long and points 45 degrees to the positive x-axis. So that's going to look something like, there's my arrow. That's going to look something like this. So we're going to call this V2, and that is 8.5 units. Okay, so before I go to adding them, so part A here asks, what are the x and y components of each vector? Okay, so we need let's look at V1 first. V1x, V2, or V1y. This one's the easy one, right? Because in this case, I'm only going along the x direction, and I'm going in the negative x direction, so my V1x is negative 6.6, but I'm not going up or down, so my Vy is going to be 0 in this case. All right. So V2, to find the V2x and the V2y, we got to draw our triangle. And again, remember the x1 is the one that goes horizontally, so we'll call this one V2x. And the y1 is, the one that goes vertically, V2y. And we know we were given that this angle here is theta. Okay, so what do we want to find first? We want to find V1x or V2x? Well, let's just pick one. So let's find V2x. Now this V2x is the side of the angle that's, or the side of the triangle that's touching the angle. So this is my adjacent, and then the longest part is the hypotenuse. And so the one that's on the opposite side of the angle is our opposite. So if I want to find the adjacent, and I know the hypotenuse, the thing that I need to use is cosine. So I'm going to say the cosine of my angle equals adjacent over hypotenuse. So the adjacent is V2x. The hypotenuse is just plain V2. And if I rearrange this, V2x equals V cosine of theta. So 8.5 times the cosine of, what did we find? I said this was theta, but really this is 45 degrees, right? We know from the problem that that's 45 degrees. Let's see here. and I got 6 units. 6.0. Circle where we're at here. All right, so there's my V2x, my V2y, so that's the opposite. I still know the hypotenuse. So there are multiple ways you could do this. The way I would probably do it was with sine. And I would say, okay, the sine of the angle equals the opposite divided by the hypotenuse. Blah, blah, blah. If I plug all that in, I think I get 6.0. Okay, so I found my components. Honestly, even if your problem is not broken into parts, like even if I didn't have a part A and B, I think this is what I would do first. Because if I do this, then that makes it makes the next part easier. Okay, so now I'm going to go on to part B. Let me just copy this stuff over. Where's my copy button? Okay. All right, so I've copied all this over. And now, vector B says determine the sum V equals V1 plus V2. All right, so the first thing I do is I do a tip-to-tail thing, right? So I'm going to draw what this vector looks like. So let me actually just pull these over out of the way here. Okay. So V1 plus V2. So I'm going to draw my V1, which goes this way. Draw my V2. I got to do this tip to tail like that. So there's my V1, my V2, and now, how can I make this a different color? So my V, if I go from the beginning to the end, should look like this. All right, so there's my picture. But now, remember, if I have this vector equation, I can turn it into two scalar equations. I could say that Vx equals V1x plus V2x. And I can say that Vy equals V1y plus V2y. Okay, going back to what I know from the last slide, let's see here. V1x is negative 6.6. V2x is 6.0. So my Vx here is going to be negative 0.6. And then my V1y was 0. I believe that my V2y is a 6.0. So my Vy is going to be 6.0. So that part's easy enough, but I want to find the magnitude and angle of my vector. Okay, so what I would always do, the way that I would go about this is I would actually redraw just my resultant vector. So I would just zoom in to essentially this part of the equation, or this part of the vector diagram, in order to find magnitude and angle. That way it's just not so convoluted of a picture. So I'm running out of room here, so give me a second to... did I get those? Copy these over to a new slide. All right. So what I would do is I'm going to redraw just this part. So I'm going to actually get rid of this. And if I were doing this on paper, I would just redraw the v vector, and I would break it into my components. So the x component has to go horizontally, the y component has to go vertically. And we just found what these are. We found that Vx was negative 6.0. Vy is 0.6. Sorry, did I do that wrong? I did do that wrong. Sorry. Negative 0.6 here and 6 here. And remember, whenever you're trying to figure out which angle to look for, you're looking at the angle at the beginning of your vector. So my vector v starts here. So this is the angle that I'm looking for. So two things. To find the angle, I know this is my opposite. This is my adjacent. So I can say that the tangent of the angle equals 6 divided by 0.6. And when I do that, so that means that theta equals the inverse tangent of 6 divided by 0.6. By the way, probably to be totally clear, I should say that this is negative 0.6. And when I did that, I got basically negative 84.2 degrees. And then to find the actual magnitude, I can say Pythagorean theorem v squared equals negative 0.6 squared plus 6 squared. When I do that, I get 6. So I get that v equals 6. So my answer is that the vector v equals 6 units at an angle of, now let's see here, this negative 84.2 degrees. Let's think about what that means physically. Well, that's saying that this angle is 84.2. The reason why it's negative is because it's going clockwise. So we don't necessarily have to pay attention to the negative. So it's 84.2 degrees, and this vector starts out at west, but then it goes north of west. So I could say 84.2 degrees north of west. And again, this would be the exact same thing as saying, let's see here, what's 90 minus 84.2? 5.8, is that right? Yeah, 5.8. So this is the same as saying, if you had done this and you had gotten, instead of my answer, if you had gotten 6 units at 5.8 degrees west of north, that would be the same answer. All right. There we go.